morning. So I want to talk to y'all about time. As a geologist, I think a lot about time, and I think of time as time back into the past. Essentially, I ask the question, how old is it? So I want y'all to think to yourself, what's the oldest thing you've touched? Maybe it's a grandparent, someone who's 80 or 90 years old, okay? Maybe you've been to Boston or Philly and you've touched Revolutionary War artifacts, hundreds of years old. Maybe it's ancient Egypt or ancient China. But as a geologist, that's not old enough for me. I study rocks that are way older than this. I actually have an example. So go ahead and hold this guy in your hand. What you're holding is a meteorite. So A, it's from outer space, and B, it's 4.5 billion years old. Yeah, go ahead and hold that in your hands. One of my favorite things about my job is I get to touch stuff from space. It's just really cool. So as I said, these are 4.5 billion years old. And you can just take my word for that, but you might be wondering, how do we know? So the way we know is by using radioactivity. It's kind of like carbon dating, but for rocks, we can't use carbon. It doesn't go back far enough in time. So we use a different system. We use potassium and argon. The way this works is that the rocks start out with a lot of potassium in them. And over time, that potassium changes into argon. And we know how long this takes. So this sets up a clock, a little geologic clock. Just like this clock here is counting down how long I've been talking. Once the rock forms, how much argon you have is that clock reflecting how old it is. So when you do that for these rocks, most of meteorites come back as 4.5 billion years old. Now some really special meteorites come back much younger than that. They come back only 500 million years old, which, yes, to a geologist, 500 million years is relatively young. So this challenges our idea of what we think the solar system is like, because the idea, with the exception of the Earth and a small moon of Jupiter, most rocks formed early at the beginning of the solar system and aren't producing new rocks since then. So one idea to explain this is people have suggested maybe this is telling us about the history of this sample. One requirement of potassium argon working is that the sample has a relatively calm history since it formed. Meteorites are not like that. You can see by looking at the rock evidence of colliding with other asteroids in the asteroid belt. Also, it was delivered to Earth by a flaming fireball falling through the sky. This is not calm. This is where my research comes in. I go around to Earth, to areas where there are craters, where we know the age, and so we can test whether or not this falling through the sky changes the age we measure. And this is important because either the system can't be used to date really old things, or maybe rocks in our solar system aren't as old as we think. Thanks.